Okay. Good evening, dear students. Welcome to my Coordination Chemistry lecture number 5. In this lecture, I would like to discuss several examples of IUPAC names of coordination compounds. So in this lecture, I would like to start examples of IUPAC names of coordination compounds or complex compounds, In particular, my view in this one is very clear. So in this topic of examples of IUPAC names of the complex compounds, two things I would like to stress. The one is, if they give the name, formula of the compound, the formula will be converted into name. That means taking the formula, we will try to write the name of the IUPAC name of the complex compound. That is one thing. The first exercise. The second thing in this one is, they will give the IUPAC name. They will give the IUPAC name to us. IUPAC name. That name, that should be IUPAC name, they will give to us. That we will convert into a formula. That means complex compound. Formula of a complex compound. So name we will write, that is IUPAC name. And the formula what we will write from the name is a complex compound formula. So these two things we are going to discuss in this lecture number 5. So extensively in this lecture, we will take the examples from the textbook, from the different books we have, to solve the formula of a question given to us. Okay. So let us try to start the questions. First of all, I would like to write a question. One question, that is, write the formula of the following coordination compounds. Write the formula of write the formulas for the following coordination compounds. Following coordination compounds. So first, what they are giving, we will see. The first one, the name they are giving is tetraamine. Tetraamine aqua, tetramine aqua, chlorido, cobalt, and inside the parenthesis they are giving Roman 3, means oxidation state, cobalt 3, chloride. So this is the first one name they are given to us to solve it. See, we all know, as per the nomenclature, tetraamine. What is tetraamine? Amine is nothing but NH3. We all know amine is ammonia ligand. And aqua is nothing but water. Aqua is nothing but H2O ligand. Rest of the thing, you know, cobalt. So up to whatever this complex Roman number given, that all should be present in a coordination sphere. So whenever the name they are given like this, the formula starting with the central metal we have to write. Then we have to write the ligands, NH3 ligands. Tetra means there are 4 NH3 ligands are present from the name, and H2O is there. H2O only. As it is a polyatomic molecule, we can keep it in a simple bracket. Chlorido means Cl. So here there are 4 NH3 groups and 1 water, 1 Cl. Total of 6 ligands around cobalt are present as per the name given to us. So in this square bracket, whatever we kept coordination entity, all the 6 ligands around the central metal are present. But if you see the oxidation state for cobalt, +3 given, Roman number 3 is +3 oxidation state of cobalt. That to get that oxidation state from this, we should write chloride outside, 2 chlorides to fulfill the oxidation state. Why? Because the number of chlorides should be 3, whether it's inside or outside. Inside the square bracket, we have 1 chloride is there, that is satisfying both the primary and secondary valencies. So this is the formula of this first question of writing the formula of the coordination compound, tetraamine aqua chlorido cobalt 3 chloride. Okay, let us see the next one. We have the next question, that is potassium. Tetrahydroxido. Zincate. They given 2 in the parenthesis. So Roman number 2 given in the parenthesis. It indicates that this whenever they started with the tetrahydroxidozincate, hydroxide is the ligand. Tetra means there are 4 are present. Zinc is the central metal. So coordination sphere consisting of zinc is the central atom. Around that there are 4 OH ligands are present. There are 4 OH ligands are present. That is a coordination sphere. And in this oxidation state of zinc is 2, to fulfill the oxidation state, the potassium counterions should present outside the square bracket should be 2 only to balance the charge. That means sum of the charges should be 0 in this given complex compound. So in such a way, we are given 2 potassiums. Okay. Next question we will see. Potassium potassium trioxalato aluminate 3. So potassium trioxalato aluminate they are given. Let us try to solve it. So whenever continuously they are given the name, that should be the coordination entity. The other one is counterion. So here from trioxalato aluminato, we can definitely understand that aluminum is the central atom in this complex. Around that, oxalate, that is C2O4 are there, 3 are there. So Al C2O4 thrice is there, and in this oxalate is -2 oxidation state. We know such things you have 3 are there means -6 will come. But the entire complex compound should be neutral. Total charges must be 0. Then how many potassium should be present outside to make it 3 oxidation state? So we have to take 3 potassiums outside the square bracket in the left side. So it is K3 Al C2O4 thrice. So in the B example and C example, B problem and C problem, we have metal name ends with the suffix 8, means definitely these 2 examples belongs to anionic coordination compounds. Okay. Next we will see the other example. Example D. Dichlorido bis. Dichlorido bis. After that, they are given inside the parenthesis ethane 1,2 diamine closing the bracket, and they are giving cobalt 3. So this is the name they are given to us. From this, we are very clear that the dichlorido indicates that there are 2 chlorine atoms are there inside along with central metal cobalt. Bis means there are 2. This ethane 1,2 diamine are there, means as ethane 1,2 diamine shortcut is En, we know. So then along with the cobalt, we can write this complex as CO. There are 2 chlorines are there. En shortcut is in the formula is En. 2 times it is there. So this is the entire coordination complex. But the name they given indicating that the coordination number, the oxidation state of cobalt is 3. To fulfill this oxidation state, there should be positive charge over the coordination sphere, as it is a cationic complex ion only they are given. They are not given complete formula name of this cobalt complex. So How this plus 1 charge came means cobalt oxidation state minus 2 is equals to plus 3. Sorry. It is cobalt oxidation state in the question given is plus 3 minus 2 chlorines is minus 2 is equal to the superscript, that means charge on the ion. Charge on the ion. So 3 minus 2 is plus 1. So that's why we have taken charge plus 1 over this coordination entity. Next, we'll take the next example. C. E. This is got over. Tetracarbonyl nickel. Tetracarbonyl nickel. Tetracarbonyl nickel 0 they given in the bracket. So if you see this name given to us, tetra means there are 4. Carbonyl is carbon monoxide ligand along with nickel. Is a complex. Is a neutral complex. So nickel is a central metal. Around that there are 4 carbon and carbon monoxide ligands are there. And even this complex compound is coordination sphere without any charge will be there, as it is a neutral complex compound. From the name, it is very clear. So NiCO 4 times is the formula of this compound. So this is the way we observed the first question. First question we have observed. A question we have given answer tetraamine aqua chlorido cobalt 3 chloride. And B question we are given answer potassium tetrahydroxide that is K2ZnOH 4 times. And C question potassium trioxalate aluminate 3 we are given the formula K3Al C2O4 thrice we are given the formula. And D question we are given the formula dichlorido bis ethane 1,2-diamine cobalt 3 is a complex ion given, that is COCl2En twice plus charge. And E question tetracarbonyl nickel 0 we are given the formula NiCO 4 times. Okay. Now in the same fashion we'll take another example from textbook. Another question I'm going to write. Let us see the question. What they can is write the formulas of the following coordination compounds. What is the question is? Write the formulas of for the write the formulas for the following coordination compounds. Following coordination compounds. Okay. So we will take the first A question in this one, sub question, that is tetraamine First question they are given to us is tetraamine diaqua cobalt cobalt 3 given, Roman number 3 given, cobalt 3 chloride. Okay. Here in this question, up to the Roman number, we can say that is a coordination sphere. In that, cobalt is a central metal, so we will write CO. Tetraamine means there are 4 NH3. There are 4 NH3 ligands are present. So we will write 4 NH3 ligands. Diaqua means water ligands. There are 2 ligands are present, water ligands. So total 6 ligands are present around this cobalt. Do remember this, both the ligands are neutral ligands. So whatever chlorides we are writing outside must be equal to the oxidation state of cobalt. So we will write Cl outside the coordination sphere, 3 Cls. So the formula of the compound is CONH3 4 times, H2O 2 times is the coordination sphere. Outside that we have Cl3 is there. Next, we will see the second one. Potassium tetracyanide. Potassium tetra cyanide nickelate. Potassium tetracyanide nickelate. They given Roman number, oxidation state inside the bracket is 2. Let us see. So whenever they started from tetra and ended with Roman number, outside potassium is there definitely. And we'll start with the coordinate sphere. Nickel is the central atom. As it is a anionic complex, the name of this metal ends with 8, clear. Tetracyanide. Tetracyanide means CN ligands. 4 ligands are present around nickel. One ligand is -1 charge. 4 ligands are there. Nickel oxidation state +2 -4 is equals to -2. So the coordinate sphere charge is -2. To neutralize this -2 charge, we have 2 potassium must be present to get the correct formula of this IUPAC name of this complex. So the formula of this complex is K2 NiCN 4 times. Okay. Let us move to the next one. C question. They started with the tris. Ethane. Tris ethane 1,2 diamine 1,2 diamine chromium they given chromium with the Roman number means oxidation state 3. After that they are given chloride. So this is the name given to us. So if you see the name up to the Roman number, chromium is the central metal. So coordinate sphere central metal is chromium Cr. And such type of chromium linked with En. En means ethane 1,2-diamine is a bidentate ligand. There are 3 ligands are there. As all 3 are neutral, chromium charge is +3 oxidation state. So to fulfill the oxidation state, we should write 3 chlorides outside to get a clear formula of this complex compound. Okay. So this is the formula of this C question. Next we'll see the D question. Amine, the name starts with the amine bromido, chlorido of that nitrito N, nitrito capital N, platinate they are given. Platinate. On inside that they are given Roman 2. So Roman 2 means oxidation state of platinum is 2 in this complex. So it is very clear when you have observed there is no breakup. As a continuous name given in this, we have the central metal is platinum. It is very clear. And this platinum is associated with ligands amine. Amine means NH3 ligand is there. So definitely we will write NH3, simple bracket. Bromido means we'll write Br. Chlorido means we'll write Cl. And nitrito N means we will write NO2. So this is the complex from the given name, IUPAC name of the coordination compound. Let us see the next one. E. We'll write E. That is dichlorido bis question. Dichlorido bis ethane 1,2 diamine, ethane 1,2 diamine, platinum oxidation state they are given 4 in the simple bracket, nitrate, platinum nitrate they are given. So it is very clear whenever we have a question like this, platinum is the central metal in the complex. So we will write platinum PT associated with dichlorido means there are 2 chlorine atoms are there. I'll give it a PT small t. Okay. And En means ethylene diamine. En is there. Bis means there 2 are there. So total of 5 coordinations completed. And this entire 6 coordinations completed. Outside this one, we have some nitrates are there. That is NO3 are there. But how many NO3s are there? Means to fulfill this oxidation state, inside the two chlorines are there. So outside, if you have two nitrates are there, definitely this oxidation state will get balanced. The entire charges will be correctly presented. Okay. So what is the formula of this one is dichloride of base ethane 1,4,1,2-diamine platinum 4 nitrate is PtCl2En twice inside the parenthesis. This all square bracket means coordination entity. Outside that we have NO3 nitrate is there. Two nitrates are present. That is the E question. Next we will see F question. That is iron 3, iron inside the Roman they are given. Inside Roman given 3. Iron 3, hexacyanidophenate 2. Hexacyanidophenate 2. So do remember, we have already done with this type of model example in the previous class. As I have already told, the name starts with the coordination starts from hexa. So these cyanides are 6 are there. Attached with iron means Fe is a negatively charged coordination entity. Okay, remaining is iron. But here, what is the starting counterion iron oxidation state is Roman 3. Inside whatever central metal is there, that oxidation state is 2. But to get a clear formula, we should know what is the charge on this coordination entity. So with +2 oxidation state in the coordination entity of iron, the charge on the coordination entity will be -4. Okay. So the oxidation state of iron, whatever is there, oxidation state of iron in the counter ion stage, +3 is there. If you take this +3 and -4 in a crisscross method, you will get a formula, correct formula of the complex as Fe4 Fe Cn 6 times thrice. So 3 coordination entities and 4 iron counter ions outside should be present for this given complex ion name. So this is the formula of the complex compound which is given to us. Okay. Next we will see another type of question. Let us talk about a different question, which is our exercise question. That is, write the formulas of the following coordination compounds. of the following. So in this, we'll see the first one, tetrahydroxo zincate. Tetrahydroxo zincate. Tetrahydroxo zincate. Zincate, inside bracket, they are giving oxidation number. So if you see this name, zinc is the central metal, is very clear. Hydroxo is OH is the ligand. These ligands are 4 are there. That's all. We don't know what is the charge on the coordination entity. To know the charge on the coordination entity, you have to add this oxidation number with the charges contributed by ligands. You will get -2. So that means -2 is the charge on this coordination entity for this given name. Let us see the next one. Tetrabromidocuprate. Also same only. Tetrabromidocuprate. Tetrabromidocuprate 2. So no doubt at all, from the above example, it is very clear. Central metal is Cu and ligands are bromine ligands are there. There are 4 ligands are there. There are no central metal. So charge will be like I said earlier for the above example, the same only here 2 minus cuprate. Why? Because the name of the metal in these two examples, in these two questions, end with the suffix ate. So charge coordination entity is anion. Next we will see the third one. Pentaamine. Pentaamine nitrito O cobalt oxidation state given as 3. So if you see this name, cobalt is the central metal. Cobalt is the central metal associated with the 5 NH3 ligands, monodentate ligands. It is very clear. Another ligand is nitrito O, not nitrito N. So nitrito O is ONO. We have to write ONO. So their total 6 ligands are there. So the oxidation state is +3 for this complex. For the cobalt only. So to know the charge on the complex ion, we have to write the oxidation state of cobalt. ONO is negatively charged 1, -1. That is equals to +2. So definitely charge on this one is +2, as it is a positively charged coordination entity. Next we will take another example. Hexaamine cobalt. Hexaamine cobalt 3. Hexaamine cobalt 3. So they closed that simple bracket for oxidation state. Outside they are given sulfate. So this is the name given to us. Hexaamine cobalt means cobalt is the central metal in this one also. So NH3 amines are there. There are 6 are there. NH3 ligands with cobalt, around cobalt. And sulfate, sulfate is SO4 2 minus. Okay. We have tried SO4 2 minus outside the coordination sphere. To know how many sulfates you have tried outside, we should be very careful about the coordination entity, as cobalt is +3 oxidation state. When the cobalt is +3 oxidation state, then what you will do is you will apply the crisscross method for this one to write SO4 thrice like this. So SO4 thrice is -6 charge, and this cobalt compass coordination sphere charge is +3. So total charge will be neutralized to get the answer. So these are the examples. Next, we'll see one final example of converting the formula into a name. Converting the formula into the name. In this question, the question is, write the IUPAC name. IUPAC name of the following. Of the following. So we'll take the first one, that is K2 PdCl4 given. So after giving K2 PdCl4, we can understand that the name starts with the potassium cation. So potassium. But the square bracket coordination entity continuously have to write in this. There are 4 chlorines are there. So definitely we have tried it as tetrachlorido. Tetrachlorido. And we know this is a negatively charged anionic complex. Metal name palladium will become palladate. With the oxidation state 2 inside the bracket. Why? Because if you do calculate, you will get the square bracket, whatever coordination entity is there, the charge will be 2, -2 coordination entity. So how this 2 came is very clear. If you have any doubt, I will give you. Potassium charge is 2. 1 potassium is 1, 2 potassium 2. And you don't know the oxidation state of palladium, keep it X. 1 chlorine is -1 oxidation state, so 4 chlorines are there, so -4. So then what is the total charge? Total charge is 0 for a neutral one. So if you do calculate, then X -2 will become 0. X is equals to +2. So the X what we are assuming is oxidation state of this platinum. Okay. Next question, we'll see B formula, that is K3 Fe C2O4 thrice. So this is the formula given to us. As it is very clear that it is also starts with potassium cation. We'll write potassium. Then we will start writing the name continuously for coordination entity. As the 3 oxalates are there, so you can write this is trioxalato. Trioxalato. As it is negatively charged anionic complex, so iron name will be ferrate. So we will write it is ferrate. And like I did the calculation for the previous one, you can easily calculate. One oxalate is -2. So 3 oxalates -6. So -6, 3 potassium is +3. So 6 - 3 is 3. So iron oxidation state in this one is 3. So Roman number 3 you have to write inside the parenthesis. See the next one. And the last one for this session. CO NH3 5 times Cl 2 Cls are there outside. So for such type of example, we know the name starts with pentaamine. Pentaamine. Cl is chlorido inside the square bracket. Cobalt is the central metal in this cobalt. Oxidation state for the complex is 3. From the formula given to us, we can calculate X value. Outside chlorines are there, so outside chlorines we'll call it as chloride. So this is the example. Several examples we observed in this session. Hope you have understand the different examples I have given to you. Even exercise questions also you can cross check it. A few exercise questions I have already left, you can cross check and you can practice the same way. So we have started with the idea of converting the formula into name with some questions. And also one question we have taken, that is the name we have taken, and we wrote the formula following the IUPAC norms in this coordination chemistry lecture number 5. So this is the end of this session. Hope, dear students, you understand these examples and their names in this session. Thank you very much. We'll meet in the next session with different ideas in coordination chemistry. Thank you.